And the list goes on and on. There's so many great examples. I think weather and human behavior are really good ones. So weather, and let's just say human behavior is a catch-all for tons of complexity behavior. Sometimes good behavior, sometimes bad behavior, typically interesting and complex. And I think it's fascinating that one of the ways we model uncertainty, have modeled uncertainty historically, we call this divination, essentially, are things like astrology or augury or tea reading, reading the tea leaves, stirring up your tea and reading the tea leaves, rolling the bones of animals and seeing how they scatter to predict something about our uncertain real world. It's quite fascinating that one of the ways humans have grappled with uncertainty and the probabilistic nature of the complex real world is to actually try to analyze it and understand it with another random process like rolling the bones of animals or how tea leaves dry in a cup of tea or things like that. Pyromancy, how the flame patterns move. There's hundreds of words for different types of divination. It's one of the most common themes throughout all of human history is trying to grapple with our observed uncertainty of the real world, of the complexity of the real world, like weather and human behavior, by trying to simplify it into a simpler random process that we can maybe try to analyze it and understand, like rolling the bones or something like that. Fascinating. If I think about a coin, this is my fair coin. If I flip this coin, this technically is not a random system. This is governed by force equals mass times acceleration, F equals ma. It has wind resistance, mass, inertia. It's under the effect of gravity. This is a deterministic physical system that technically I could model on a computer with equations and do a pretty good job of predicting. But as far as I'm concerned, as a human observer, there is too much uncertainty in my measurements, in my ability to model this in my head. So for me, a coin flip is a random or uncertain event that I have to model probabilistically. Statistics is the flip side of that, where we actually, the data is known, the samples are known. So we have data is known. So let's say I flip the coin 10 times or 100 times and I measure, I observe that system. And now we're trying to say something about the probability distribution. So the probability distribution is